Martin, welcome.
Thank you. I'll keep this. Thank you. Hello, everyone. Thanks, Jeremy, for giving me 10 minutes here. And in these 10 minutes, I'd like to talk to you about servers. Obviously, so I work at Google Developer Relations, and obviously at Google, we love servers. We have plenty of servers. I have more pictures. And I have to do my usual disclaimer. Those servers, they don't glow green by themselves. This is an artistic effect put by the photographer to make them look nice. Those pipes are actually painted in Google colors. Yes, I have to admit that. So this is a refrigeration machinery in a data center. A little bit of trivia. 100 hours of additional video footage on YouTube. How much time do you think it takes us to ingest an additional 100 hours of video? The same as adding 1,000 new Android devices, activating 1,000 new devices. And also the same as counting 3 million searches. So yes, I guess you guessed it. This is 1 minute at Google. And we also have a couple of services that operate above 1 billion users. The whole point being this needs a lot of infrastructure, and we've been building this infrastructure for the past 15 years. And I'm here to tell you that you, as startups, if you're ambitious, you can use this infrastructure to power your own business. So first of all, let's do a little bit of recap in history, because yes, I said for the past 15 years, we've been not only building this infrastructure, the hardware, and the data centers, we've been building the software that makes these hundreds of thousands of servers work together. And we've been constantly publishing scientific papers explaining exactly how this works. So Google File System, that was in the very beginning. When we first started indexing the web, there was no file system able of holding the web and not the web plus its index. So we had to invent that. MapReduce, I guess a lot of you heard about it. There is a whole community around the open source implementation of that idea, which is called Hadoop now. The same happened with Bigtable. That's our internal NoSQL database. The paper we published about it spawned this big NoSQL movement that you know today. Kind of the same thing is happening with the Dremel. Dremel is the internal name of something I will talk about, which is called BigQuery. It's a big data, data crunching database. And the trend continues. Actually, from 2010, you see Spanner, Colossus, F1. Those are systems we have running internally, which are not yet packaged as systems that you can use externally. But I wanted to show you this to show you the trend. Just for those who are interested in database technology, actually Spanner and F1 are the return of SQL. NoSQL databases were designed so that you could get over the hurdle of one big server, which is hard with a SQL server. And the way it was designed was that a lot of features were removed to make the scalability possible. So we are putting those features back, full SQL support and so on, with Spanner and F1. So what is there in this for you? These are the external names of these products. So you have Google App Engine, our platform as a service, now released in general availability since 1 week, I think. We have Compute Engine. This is infrastructure as a service, basic virtual machines. BigQuery for analytics, and a couple of storage options. Cloud storage for basic files, and 2 database options, Cloud SQL and Cloud Data Store. But let's focus on App Engine. Do you know what this is? Well, I guess you guessed it. It's a service that today exchanges 350 million pictures per day. And that, by the way, turned down an offer from Facebook. I read about it in the news. I know nothing about the backroom story of this deal. This is, of course, Snapchat. And yes, Snapchat was founded as a company with 4 people, went to 12, now they are about 30. But a very limited number of people. And if you ask yourself, how can these people build a platform that can exchange 350 million pictures a day? Well, the answer is they didn't build the platform. Google is building the platform, and Google is handling the traffic and the communications between all the servers that power this service. That's the secret sauce behind Snapchat and countless other startups who also grow to a very ambitious scale without having to build and figure out the server infrastructure, network setup that makes this possible. So how does this work? App Engine is a platform as a service. It knows about 4 different languages, Python, Java, Go, and PHP. And it lets you focus on your code, and your code only. So as startup developers, you really shouldn't be focusing on anything else but the code that does your added value. Any piece of code you write that handles server scaling or scripts you write for deploying your stuff, all that, you're solving problems that have been solved before and that have been solved by hundreds of engineers at Google, and that you should not be solving. You should be solving the problems of your customers, not the problems of your developers. A peek under the hood, what is the typical App Engine architecture? So you will have your front-end instances, and any state they have, you have to persist off your servers. That's the key to scalability. You have to understand that all of those servers can die at any time. Any piece of state, be it the fact that someone is logged in or the contents of a shopping cart, all that you save to a database. There is a database available, the data store, a NoSQL database. And for performance reasons, you will usually go through a cache before you hit the database. And now if you look at this picture, your instances are completely exchangeable. Memcache and data store are services, something that is managed by Google. So any server in there can die at any point in time. And now try to think what amount of code you would have to write if you were to put up a platform that has no single point of failure, where any server can die, that can actually resist, and that's our building contract, that can resist a complete data center failure. A meteorite crashes on one of our data centers, it is in the contract that your application is not supposed to stop working.
Martin, 2 more minutes.
Yep, I have them. We have SongPub here. So they published a nice paper about how they did their infrastructure and exactly the amount of work they did. So they went through 100K daily active users, 500K daily active users, 1 million daily active users. With more or less the same code, there was about a week of optimization at the 500K and the million daily actives. But that's it. The rest, the scaling, was handled by Google and by App Engine. Okay, let's skip this one because I want to get a little bit further. Right here. Okay. 1 more minute of how much this costs. Of course, App Engine has free quotas if you want to try. That's fine. You can find 2,000K vouchers, $2,000 vouchers about everywhere. And for startups, and specifically for startups, we have a $20,000 offer, which is called the Startup Pack. And this one you will not find on the net. So please come and see me if you are interested.
Thank you.
Also come and see me if you are interested to talk about Android featuring, G+ sign-in, or just talk about code. I love talking about code. Thank you very much.
Thank you, Martin. Thank you.